So I'm going to walk you through the decimals mastery check just because it kind of has every skill that we will want to master by the time we're finished with this unit. So I can kind of walk you through all of them for practice. So here we go. The first few mainly had to do with place value. If you can think back to any of the small groups, if you've met with me on place value so far, or even just checked in with the notes, anytime you get to the decimal point, you're saying the word and. And then everything from there, from left to right, they kind of mirror out. So there's only this one ones column. Okay, so I'm just going to put a one. This is my ones column, right? My ones place value. And then from there, I just start adding zeros. So if that's my ones, this is my tens. And then this is my hundreds. So every time after, I'm just adding one more zero. So that means that that place value is my thousands because now I'm going to have 3 zeros sitting there, right? Well, it's the same concept when you go on the decimal place value side. So this is all whole numbers, and this is my decimal place value side. So again, there's only one ones column, and then after that, it mirrors. So if this is my tens, this is my tens, 10, 100. I'm still adding just an extra zero every time I go through. So anytime you're asked questions about the place values, this is a really good way to just kind of get it all out on your paper so you can refer to it. And then the only thing that's different on the decimal place value side is everything ends with THS. It's like a lisp side, okay? So tenths, hundredths, thousandths, okay? I don't have enough room to write that after each one, but that's the difference. This is just tens with an S, hundreds with an S, thousands with an S. The place value, the decimal place value side is your THS. Okay. So automatically when I'm looking over here, I see ones, tenths, thousandths, right? So I know I'm looking in my decimal place value side with those, right? So here we go. It's saying find the digit in the ones place, the tens place, and the thousands place. So there's only one ones column, and that's always sitting right there to the left of the decimal point. So I already know for sure that that 9 is what is sitting in the ones column because it's right there on the left side, okay? Tenths is going to be right here, right? And I can refer to this now that I've drawn it out. I can refer to it really easy. So what is the digit that's sitting to the right of the decimal point? It is a 4. Okay, so it's quick, easy reference. And then thousandths, right? THS, so I know I'm on the decimal side. Tenths, hundredths, thousandths. So that's 3 spots over from the decimal point. 1, 2, 3 spots over. So that's where my 6 is. So again, I would go through and just write this out. There's one ones, and then from there, you're just mirroring. So this has a 0 and a 0. This has 2 zeros, 2 zeros, 3 zeros, 3 zeros. And then you can refer to it really easily for any of your place value questions. That is my recommendation. I think it really does help. So, okay, write the following number in standard decimal form. It just means write it as a number. Standard form just means like normal. So my main thing that I am looking for right now is the fact that I just said anytime you get to a decimal point, that's where you say the word and. So now I have something over here, a decimal point, and something over here. Okay. So I can say and right here. This says 1, 1, and 12 10,000ths. Okay, that's really weird, right? 12 10,000ths. That doesn't even sound like a number. Usually, what I tell kids is when you're on the decimal place value side, all you're doing is saying the number like you normally would, just as a normal number. And then you say the place value that it ends in. Where is it sitting when you're finished? Okay. So when I read 12 10,000ths, I see that 12 is a number, right? That's just a regular old number. So I need the number 12 somewhere, right? And then that 10,000ths spot is where I need to stop. Okay. So again, let's look at this. This is my ones column. So this is my tenths, hundredths, right? Thousandths with the THS, right? And then I have one more. If this is my thousandth, this is my 10 thousandths because I'm just putting one more zero on there, correct? Whee! So 10 thousandths. This is my place value, 10 thousandths. So I just need the number 12 to end there. So that means my 2 has to sit right there, and I'm going to put the 1 right here, and everything else just gets filled in with zeros, right? You just fill it in. So that way you have the number and it lands in that place value that you're supposed to land in. So that's how I go through it. Yeah. I'm going to plop this in here. 1 and 12 10 thousandths. Okay, so again, it looks really funky, but you just have to pay attention to what is that number and then what's the place value that has to sit in. All right, so for these, I would suggest you're trying to go from least to greatest, the lowest amount to the largest amount. Well, there's only 4 of them. So one of them is really nice because I can tell automatically if you're looking on the whole number side, this has a 2, a 3, a 3, and a 3. So automatically I know if I'm looking for the lowest number first, that's where this goes, right? It has a 2. So I'm already done with that. Cha-ching, cha-ching, completely done, okay? Don't even need to worry about it. All right. So now I'm ready to keep going. I have you don't have to go through and do this, but I do. I just stack everything. So I have 3 and 2/10. I have 3 and 29 hundredths, right? You're just reading the number 29 and it lands in the hundred spot. And then this is 3 and 209 thousandths. Okay, so you just read it as 209 and it ends in the thousandth spot. So I go through and I'm like, they're all 3s in the ones column, so that doesn't tell me anything. I can ignore that. So I go to the next place value over, they're all 2s, so that doesn't tell me anything. So if I go to the next place value over, I have a blank, a 9, and a 0. Well, I know the blank just means I could put a place value 0 there, right? So out of these 3 numbers, do I have anything that stands out as being different? Absolutely. So this is my 9. It's showing me that the 9 is greater than zeros, right? So this is the largest number out of all of them, the greatest. So I can automatically go through and fill that one out now. 3 and 29 hundredths is now my largest number over here, okay? So again, woohoo, I get to just cross that out and be done with it, right? And I'm only left with these 2. Okay. So now I'm looking at this is gone. Yep. Now I have zeros. They match. That doesn't tell me anything. It's a tie. So I got to go next door. And when I go next door, now I have a 0 in this place value and I'm comparing it to a 9. So between 0 and 9, those are really easy. You're just looking at that one place value. Obviously, a 0 is less than 9. So that means this entire thing is less than that number. Okay. So 3 and 2/10, even though I've added a few zeros, 3 and 2/10 is going to be less than 3 and 209 thousandths because all I did, I ended up comparing that 0 and the 9. This is less than. Okay. So, ta-da! And I fill in the rest. Okay. So that kind of takes you through how to go through and compare. Okay. The rest of these questions that are coming up when they're talking about adding and subtracting, if you can remember from the notes, or if you've met with me in a small group, I remember all the soldiers line up in a row. They have to be straight in a row, right? So all the soldiers line up, A, S, all the soldiers, and addition and subtraction also have to line up in a row. So that's what I do with my decimals. That's how I remember it. I stack them automatically, and then I just pay attention to what is the actual operation I'm being asked to subtract for this problem. And then I just fill everything else in around it. Okay, so I have 83 and 8/10. So I'm going to fill that in. And then I have 4. This is where kids get kind of confused, right? It's the number 4. It doesn't have a decimal in it. So where is it supposed to go, right? Every single whole number out there has an invisible decimal. They call it invisible math. You just don't put it down unless you absolutely need it. So unless you're going to put something there, people just leave it off. But technically, it's always sitting there. So if I'm going to line this up correctly, my 4 needs to go here. It's on the whole number side. Okay. And I'm going to do a place value 0 just so I've got something sitting there. And now I'm ready to subtract, right? 8 minus 0. If I have 8 and I don't take anything from it, I still have 8, right? Now, if I go next door, if I have 3, someone can't take 4 away from me. I don't even have enough. So I'm going to go next door and borrow. When I borrow from that tens column, it goes down 1, right? And now it's going to go and sit next to my 3, okay? So this is from my tens column. I borrowed 1 from it, and it's coming right next door. So now my 3, I added 10 more to it. So it's out now at 13, okay? 13 minus 4, now I'm at 9, okay? And then 7 minus 0, 7. Okay, so your main thing is just make sure all your soldiers are lined up in a row. Addition and subtraction line up in a row. So line those suckers up. Pay attention to make sure you're doing the right or the correct operation before you begin, because sometimes that messes us up too. I accidentally subtract when I'm supposed to add or whatever. So, yep, that's it. 79 and 8/10. All right, moving on. I guess I'll type it just to... I don't know if that would bother anybody if I didn't. Okay, so rounding. Here we go. Rounding is tricky for people, so that's okay if you're frustrated with this. So here we go. If you have not yet checked out my rounding video, please check it out, okay? It'll really help. You can fast forward, rewind. It's not an ed puzzle, so you can go as quickly as you need to. This is round to the nearest 10th. So step 1, identify where the heck is tenths, right? So remember, there's only one ones column, right? So if this is my ones, right? This is my tens. So this is my tenths. Remember, everything on this side has the THS on it. Yeah. Sorry, that's horrible handwriting. I'm using my trackpad. Okay. So anyway, we've identified that the first place value behind your decimal point right here, that's your tenths. Okay. So step 1, once you identify it, underline it. Tenths, tenths. Then chop it off. Okay. This is the last place value we're going to keep. No matter what, these are going to become zeros. Okay. No matter what. So now that we've identified this is my 4, right? I'm going to look next door. Whee! Because I have to figure out, am I supposed to round up or round down? Now, in my video for rounding, I say I'm all about the weird ways to remember things. I have the worst memory in the world, and it just helps me get through math. So I'm not against rhymes. A lot of people are like 4 or 5 or more, let it soar. 4 or less, let it rest. I think I've heard some kids say, right? The problem is from year to year, kids either can't quite remember what number is in that. So they're like 4 or more, 5 or more, let it soar, or they just don't remember like how to apply it once they say it out loud. So I just want you to try to use logic this year. So when you are looking at this, this is the number 43, correct? You're just focusing in on what you're trying to round. So just like almost like horse blinders, right? Those are the only 2 numbers we're going to look at. If it's at 43, you're trying to think of it on a number line itself, okay? So if it's at 43, right, I think that means we're kind of between 40, right? So I always just look at the number that we've got right there, 4, so 40. And then the next number up would be 50, okay? We've gone 3 hops so far towards 50, 40, 41, 42, 43, okay? If we're on this number line and we're trying to get all the way to 50, are we closer to 40? Or are we closer to 50? And you're just picturing that and how many hops you've gone to the next number to figure out what the heck to do here, okay? So if I went 3 hops, that's 43. But now I need to get all the way to 50. So I'm going to try a different color, okay? So it's 43, 44, 45, 46, 47, 48, 49, 50, okay? You could draw a number line too, but it's not as easy with my trackpad. So anyway, how many hops are we away from 50? a lot more. Okay. So we're actually closer to the 40. And that's how I try to remember. This is just logic. If you're trying to round your numbers, you're just asking yourself, which one are you closer to? So no rhyme needed here. I know for sure that 43 is closer to 40 than it is to 50. So that's all I'm going to do. Okay. I'm not rounding up to 50. I'm going to just round down. So everything becomes a 0 after that. Okay. If you want to, you can answer this as 1 4/10. You could also answer it as 1/400,000. Either way. Okay. So you can keep those zeros on there or not. It's up to you. They mean the same thing though. It's the same value. Okay. So just wanted to point that out. I wonder if I could do this real quick. And no, it's not letting me. I wanted to try another one. So, okay. So now when we're multiplying, if you've worked with me so far, this is my fun little cheat method. It's a great life skill to have. Okay. Yes, you can go through and actually multiply it all out if you want. It just takes a lot longer. Okay. So the very first thing I'm noticing right now is that I am taking a decimal and I'm multiplying it by a number that's also a place value, right? Thousands, right? Ones, tens, hundreds, thousands. These are all place values. Yes, yes? Okay. So when we are multiplying by a place value, we get to use this cheat method. Okay. So that's what I mean by multiplying by a place value, 1 or 10 or 100 or 1,000 or 10,000, whatever. Okay. So when you're using this little cheat method, you're asking yourself, okay, if I am going to multiply by a place value, all I have to do is count how many zeros there are in that place value. So in thousands, I have 1, 2, 3 zeros, correct? There's 3 zeros there. All right. And I know if I multiply by 1,000, I have to ask myself, if I'm taking a number and I'm multiplying by 1,000, is my number going to get bigger or smaller? So if I had like $1, if I had one, right, $1, and I multiplied that by 1,000, am I going to end up with more money or less money? Hopefully you're thinking more, right? Your number is going to get bigger. So look at what you're multiplying it by. If we have this original number of 326 thousandths, right? And I say, I need my number to get bigger. I know I'm multiplying by 1,000. So that means my number is going to get bigger. If I hop this way, right? If I take my decimal point and I move it over here, is my number getting bigger or is it getting smaller? I went from 326 thousandths to 3 and 26 hundredths. If I move it one more, I would get 32 and 6/10, right? If I would move it again, I would end up with 326. Do you notice my number is getting bigger, right? I had nothing here on my whole number side. Then I had a 3. Then I had 32. Now I have 326. So moving it to the right definitely makes my number bigger overall. So that's how I'm checking to make sure I'm going to move my decimal point in the correct direction. Okay. So in general, when you are trying to multiply by a place value number, ones and zeros, right? All you have to do is count how many zeros you have. 1, 2, 3, right? And that's how many hops you're going to move your decimal point to make your number bigger. Okay. So I just was showing you how to make sure you're going in the correct direction. Because if I hopped the decimal this way, my number would be getting smaller. Okay. And we don't want to do that. So instead, we want to make sure that we're hopping it in the correct direction. So I know I need to hop it 3 times. 1, 2, 3. And that gives me 326 as a whole number. Okay. I did not have to write anything out. I didn't have to use any algorithm for that. Right. Okay. So if I was going to take that same number and I'm multiplying it instead by 10. Okay. If I was going to multiply by 10, right? 10 has how many zeros to it? Just one. right? So it's still a place value, so I can use this little cheat method, but it has 1 0 to it. So I would be making my number bigger by 1 hop instead. So I would be placing it right there, and my answer would be 3 26/100. Okay. So it all just depends on how many zeros you have in that place value when you're multiplying. But all you do is hop it around, and that's how you get your answer. Okay. Always make sure that you're going in the direction of making it larger, greater. Okay. Um, so we ended up with 326 as our whole number. Okay. Whee. All right. This one, I'm glad it follows this actually. This one is showing you I have a decimal. Is this a place value? It is not. It's not a tens, a hundreds, a thousands. It's not a place value. So that cheat method is no longer relevant. Okay. Now we actually do have to solve it by hand, like longhand, right? So going through very quickly, your rule number 1 is to ignore. All right. You guys remember this. Ignore your decimal and multiply as if they're whole numbers. So if I look at this, 42 hundredths, right? And I ignore that decimal point. Now all of a sudden I have the whole number 42, right? And I'm multiplying it by 2. Okay. This math should not be freaking you out right now. Okay. So 2 times 2 is 4. 4 times 2 is 8. Ta-da! So the actual multiplication part was not tricky, right? Now the next part is just looking at the problem in general and saying, how many digits do you have on the decimal place value side? Okay. So if you look at the whole number 2, remember there is a decimal point sitting there. It's just invisible, right? Do I have any digits to the right of it? No, I do not. Okay. So that doesn't have any. And if I look at 42 hundredths, I'm counting how many digits do I have on the decimal place value side. This is my whole number side. This is my decimal place value side. So I have 1, 2 on the decimal place value side. So if I have 2, I need to have 2 in my answer. So I'm making it match however many there are in your problem, how many you have in your answer. So I always tell kids to remember, like when you're starting your multiplication, right, the whole process, you always know to start here in your ones column. So it's the same thing when you're counting for your decimal place values. Start in your ones column. So I have 1, 2, and that's all I need. I need 2 digits on my decimal place value side. So I know I need to put my decimal point there. That way it will match the total number of decimal digits I have in my problem. Okay. So we ended up with 84 hundredths. And I'm pretty sure if you forget the 0, it just like reminds you, but you don't get it dinged. I don't think it would count it as wrong. Okay. Oh, this is a good one. Okay. So 5 divided by 8. A huge part of this problem is just knowing what goes inside your box. Okay, so if you've worked with me so far on this, the first thing you see goes inside the box. The first number you read goes under your bed. Okay, I pretend like you're cleaning your room. When someone's cleaning your room, or when I was a kid, the first stuff I would see, I'd try to shove underneath my bed. It would also go in the closet, but so I just pretend that this is my bed, right? So the first thing that you see always goes underneath your bed. Okay. And then the second number is the divisor. It's the one that's going to be at the door. So a lot of kids are in the habit right now of saying, oh, 5 is the smaller number, so it's going to go on the outside. It doesn't work like that anymore. Now that you're a big kid, you have to start realizing that you can take a smaller number and chop it up into pieces. It just won't give you a beautiful whole number as an answer, but it is possible, right? You can take 5 pieces of candy and chop them into 8 pieces, right? For sure. So that's what we're going to show here. Okay. So just to walk you through the process, it's just like any other division problem, but there's a few extra steps when it comes to decimals because we don't use the word R anymore. R or remainder, that's a curse word for me. Okay. We're not using it anymore. We are going to use decimals or fractions to show like what it really is in terms of numbers. So if I have 5 pieces of candy, easily with a whole number divided up into 8? Absolutely not, okay? So instead, if I know I can't, this is what you get to do. Add a decimal point, bring it up into your answer, because that's where it's always going to go with division. Okay, so as soon as you write it here, bring it straight up. But then you get to add a 0, okay? Did I change the value? At first I had 5, right? Now I have 5 and 0 tenths, I guess. No, it's still worth 5. I could put a bazillion zeros after here and it would still be worth 5. So it doesn't matter. I did not change the value. Okay. The lovely thing is though, now I can say 8. 8 won't go into 5, but 8 will go into 50, right? So we could say that if we're going to make sure it doesn't go into 5, right? So if it goes into 50, that's where we need to slide over and put our answer. So I'm going to say 6 times 8 is 48. Okay, so notice my 6 went above the 0 because that's where we slid over for our problem. And if you remember, we did the multiplying, right? 6 times 8. Now we're ready to subtract. Okay, so we always multiply and then we subtract. So I have 2 left over when I subtract, right? And then I'm supposed to bring down, but there's nothing to bring down. Do I put R2? No, I do not, because we do not have remainders, okay? So no remainder. Instead, what do you think I get to add? I'm going to add another 0. So I'm going to add another 0. Did not change the value. This is still just worth 5. But now I get to bring it down here. Okay, the whole purpose for this is so I can keep going. So I had something to bring down. Now I'm ready to repeat the whole process all over again, right? So now when I repeat, I'm going to ask what times 8 will get me close to 20 without going over, right? So if I do 2 times 8, I'm going to get 16, correct? After I multiply 2 times 8, I'm ready to subtract, right? And then I have 4 left over. So I did subtract. Now I'm ready to bring down. I don't have anything to bring down. What do? I can do a 0 because it doesn't change the value of my 5. This is still just worth 5. But I have a 0 to bring down, right? And the whole point of bringing that down is so I can keep going. I'm going to repeat my process and say, what times 8 gets me close to 40 without going over? So I'm in my multiplying step right here. And now I know that I can do 5 times, oh my gosh, like glitch, sorry. 5 times 8 is 40, right? So now I'm ready to subtract. Ding, ding, ding. All right, and now I have 0. Now I can end my problem, okay? So again, it's the exact same steps: multiply, subtract, bring down, repeat. I just happen to have a decimal point that I added in so I could keep using zeros to keep my problem going, okay? So no more R, right? Instead, we have 625 thousandths, okay? And here we go. All right, here's another one. This is our bigger, challenging one. So if you are not ready for this, you do not have to keep watching. This is the challenging part, okay? So again, the first number that you see, what are we supposed to do with it? First number you see goes under your bed, right? So here's 98 6/10 on the inside. That's called my dividend. And then at the door is my divisor, and that is 68 hundredths, okay? So your main rule when it comes to division is you always want your divisor to be a whole number, because this is weird, right? Okay, so I need this to be a whole number. And the only way I can turn this into a whole number, if I hop it this direction, I'm still stuck in the same problem. It's still a decimal point, right? But if I start hopping it in this direction, bloop, bloop, and it sits right here, that gives me a whole number. That gives me the whole number 68. If I have 6/8 with a decimal point sitting right here, that's a whole number, okay? So if I go twice to the right here to turn it into a whole number, I have to do the same thing to my dividend inside my box. So twice to the right over here, that means I'm going to do twice to the right over here, okay? If I move my decimal point twice to the right and I end up with these weird spaces, that's a place value holder right there, okay? If I only needed to hop it once over here, I would only need to hop it once over here. If I had to hop it 5 times over here, I'd need to hop it 5 times over here. So you just need to make it match, okay? So now I'm going to kind of like redo this. So we ended up with 9,860 as your dividend. And on the outside, we ended up with, geez Louise, what is with my pen right now? We ended up with 68, correct? Which is not very fun. That's pretty big, right? However, if you look, I know 68 is not going to fit into 9, right? I can't make groups of 68 out of 9, right? But if I slide over to 98, I know for sure I can. And I know I can't make 2 groups of them. So I'm already ready to go with this problem. I know 1 times 68 is going to get me 68, right? And I can subtract. So again, I did multiply, subtract, bring down, repeat. Those are going to be my steps, right? So when I subtract, I end up with 30, okay? So I did subtract. Now I'm ready to bring down. You just bring 1 down. That is it. Bring 1 down, okay? So unfortunately, I give you guys like a fact chart, but my fact charts, I think, only go up to like, I don't know, 30, something like that, maybe. So I'm just going to try to estimate, okay? So I'm going to say 68 is, we're going to round that to 50, okay, which is half 100, right? So I'm going to say, I would be able to fit, right, 2, 4, 6 sets of 50 if this was 300. 6 sets, but this isn't really 50. It's bigger than that. So I'm going to try for 5 instead. So I'm going to try 68 and I'm going to multiply that times 5 to see what that ends up getting me. And that's just my best guess estimation right there. Okay. So what I say is anytime you have to actually solve things by hand over here, just make sure that you don't actually go through and erase anything, because you may end up needing that math fact 1 more time or 2 more times even. And then all of a sudden you have to redo it again. So if I'm working this out and taking the time to do it, then you want to make sure that you are actually going to save it. Okay. Some kids scratch it out too. I don't know why. Just leave it. That way it's there just in case. Okay. So we had 8 times 5 is 40. 6 times 5, 30, plus the 4 more. Okay. So 68 times 5 got me 340. Way too much. Okay. So again, I'm going to leave that there. Okay. Just in case I need it later. And I'm going to try to go 1 less than that now. Right. So I know 8 times 4 is going to get me 32. Right. And then 6 times 4 is going to get me 24 plus 3 more. So I have 272. That I can work with, right? So again, leave all that stuff there because you don't want to erase it. But now if I'm at 272, I know I'm over here. I'm trying to get my, where's my little, there it is. Okay. So now I'm ready to say times 4. So 4 times 68 is 272, right? And that was my multiplying, so I'm ready to subtract, right? And when I subtract, I have to borrow here, right? Borrow, and I'm left with 34, okay? So 34 was whenever I was subtracting, I'm ready to bring the next one down. I draw arrows because especially like right now, my handwriting is horrible because of this trackpad. So it just kind of, oops, I don't even know what I was doing. It just helps you keep track of your place values and your columns and all that good stuff so you don't accidentally forget something. It just keeps you from getting a little too messy. So here we go. All right. So 340 is what I have now, right? Oh my goodness, that looks familiar. So thank goodness we did not erase that. So I'm done, you guys. I just know that 5 times 68 will get me 340. And I know when I subtract, I'm left with 0. So that's a great example of showing why you don't just erase stuff, okay? And again, I didn't even need to have a decimal in my answer. Technically, it's still sitting there because when I moved it over, it was sitting right here. So the decimal doesn't even really need to be typed in there if we don't want it, okay? 145. And we are ready to clear that one out. Okay, so again, I'm still seeing kids like when you're lining them up like this to solve, you are still stacking your decimal points and it just adds so many more steps for you. You do not need to do that. You can just ignore them. Okay, so again, if I ignore my decimal points here, it doesn't really make my life too much easier. They're still really big numbers, right? So if I go through and I pretend that they are whole numbers instead, it doesn't really solve, like it doesn't take anything away, right? I'm still stuck with the same big problem. So I'm going to go through, I'm pretending I'm the 3 and I'm handshaking all the way down. I'm meeting everybody at the party, right? So I'm doing 6 times 3 to get my 18. 3 times 0, 0 plus 1 more. 3 times 0, 0. And 3 times 9 is 27. Okay. Now, whenever I'm done with that place value, I put an X and then underneath I put my place value 0. So that way when I slide over to the tens column, that's also where my answer is going to slide over. So now I'm the 5 and I'm meeting everybody at the party. So now I'm shaking my hand all the way through again, right? So again, if I am going through, if I'm doing 6 times 5, I'm going to cross this out too so I don't get confused. 6 times 5, I'm going to have my 30. So I'm going to carry my 3, bring my 0 down, right? 5 times 0 is 0 plus 3 more. 5 times 0 is 0. And then I have 9 times 5, which is 45. Okay. Even with my sloppy handwriting, I still have pretty good columns going. So just make sure that you guys are doing that because it can really mess up your problems if you don't have your columns correct. So now that I'm done with that place value, notice I have 2 scratched out. So that means I need 2 place value holders. So that way when I move over to my 7 in the hundreds column, that's where my answers are also going to start. Okay. I'm also going to scratch this out so I don't get confused. And now I'm the 7 and I'm at the party and I'm going to meet everyone. So I ended up having 7 times 6. So I'm going to carry over my 4, bring down my 2, right? 7 times 0 is 0 plus 4 more, right? 7 times 0 is 0. And 7 times 9 is 63. So again, horrible handwriting, but at least my columns are there, right? So now you're ready for your last step, which is to just add all your partial products, right? Because the entire answer is called your product. So these are parts to your product. I'm going to add my partial products, okay? This trackpad is so silly. Before I go through and I submit anything, I'm just going to go through and double check. Okay, I believe I'm correct on this. Okay, believe so. All right, so this is not my full answer though. These just happen to be the digits that I had, right? These are the digits that are going to be in my answer, but it's not my full answer yet. So I went through, I kind of ignored my decimals. I multiplied as if they were whole numbers. Now I'm ready to go back into the problem and count how many numbers are on the decimal side. 1, 2, 3, 4, 5. So I have 5 numbers on the decimal side because the 9 is on the whole number side. The 7's on the whole number side. All the rest are on the decimal side. So if I have 5 in my problem altogether, I need 5 in my answer. So once I count over 5, that tells me exactly where I need to put my decimal point, and I am ready to input my answer, right? Ta-da! Okay, one more problem. Here we go. Okay. Last problem. Woo! This is decimals with expressions, which is crazy. Or sorry, order of operations. So here we go. You are using your order of operations, which is, if you remember, PEMDAS, right? Please excuse my dear Aunt Sally, right? And the M and the D, the A and the S are side by side because they're equals. It's just whatever comes first from left to right. Okay, so that's why I draw those arrows. Do we have anything to solve inside parentheses? We do not. Okay, we have parentheses, but we don't have anything to solve inside of it. It's just a number sitting there. So check, check. Do we have any exponents? Yes, we do. Okay, so we have an exponent right here. So this exponent doesn't mean 1 and 4/10 times 2. It means 1 and 4/10 times 1 and 4/10, right? So that's where the 2 comes from. It tells you how many times you're going to multiply that by one another. So technically, I'm doing 14 times 14, and then I can go through and add in my decimal points when I'm done, right? So 4 times 4 is 16. 4 times 1 is 4, plus 1 more is 5, right? I'm done with that 4. So I'm going to do a place value holder. And now I'm ready to move on. 1 times 4 is 4. 1 times 1 is 1. And then I'm going to add my partial products. So now I have 196. And if I look at my problem, I have 2 digits on the decimal place value side. So I need 2 digits on the decimal place value side in my answer. So that part becomes 1 and 96 hundredths. Okay. So I'm going to erase all of that. This part right here is going to become 1 and 96 hundredths instead. Okay. And that, if you notice on that side part, let me do this real quick. All right. So over here, if you notice, there's 6, and then inside parentheses, we now have 1 and 96 hundredths. Boop. Like, do you know what it means when they're shoved together? Do you remember that? That actually means that we need to be multiplying. Anytime things are shoved up against one another without an actual operation symbol there, that's what that means, okay? So let's go through and kind of reevaluate this in terms of what's the next step when it comes to order of operations. I have a division, subtraction, and multiplication option. So when you're dealing with order of operations, we don't have any more parentheses, we don't have any more exponents, multiplication or division, whichever comes first from left to right. So that means I'm going to go through and I'm going to solve this part first, okay? The first number that I see goes inside the box or goes under my bed, right? And that 8/10 goes on the outside. If you remember, we want this to be a whole number, so I'm going to move it once to the right here, once to the right here. So that gives me 8, and then 97 and 6/10. Okay, so this is what I'm really trying to solve. 8 will go into 9. I don't even know if I'm going to have room for this. Oh boy, let's try to again over here, right? I would not normally recommend going all over the place like this, but again, this is not your regular piece of paper, correct? Okay, so if I'm right here, I'm going to try to work it out up here. If I have my decimal point now sitting here, right, we've shifted it, bring it straight up into your answer so you do not forget. That's step 1. Okay, now we're ready to go. So 8 will go into 9 once, right? And once I'm subtracting, I'm ready to bring the next one down. So that gives me a 7. And I know that 8 times 2 will get me 16 with 1 left over, right? And I'm ready to bring the next one down, which is a 6. Yay, so this one's going to even end evenly pretty quickly, right? So the main thing with this division problem is just making sure that you keep your columns straight. So that way when you bring your decimal up, It stays where it's supposed to be. So this is now rewritten as 12 and 2/10. And then I'm bringing the rest down, minus 6 times, I'll even rewrite it like this just for us, times 1 and 96/100, right? Okay, so here we go. I'm going to erase as much as I can, even though it won't give me like a huge eraser for some reason. It's very, very, very annoying. But here we go. All right, so here we go. Sorry, I may actually end up leaving a little bit, which I know is just horrible. It's torturous, but okay. Okay. So now whenever I look at this, you guys, I have one little part left. So I have a subtraction and I have multiplication. Which one would we do first? Well, I'm still on this stage for multiplication and division, right? Still on the stage. Multiply first, then we will get to the addition and subtraction part. Okay, so we're going to multiply first. So I have 196 times 6, right? I'm just going to pretend like the decimals don't exist right now. So 6 times 6 is 36. 9 times 6 is 54 plus 3 more. And then 6 times 1 plus 5 more. Now I have my digits, right? But this isn't exactly my answer, right? I have to look back. I ignored them. Now I need to count them. So if I look at my problem, I had 2 numbers on the decimal side here. And this is a whole number, so I don't have anything on the decimal side here. So altogether, I have 2 numbers on my decimal side in my problem. So I need 2 numbers on the decimal side of my answer over here. Okay. So again, boxing it in. This is what I just solved, and it became 11 and 76/100, right? And I'm going to bring the rest down. So now I'm at 12 and 2/10 minus 11 and 76/100. Okay. Whew. Okay. Again, I wish this eraser, I'm sure I'm probably doing this wrong. There's no way that they would actually like just give you this as your only option for an eraser. Okay, so I'm trying to get rid of all of this stuff because I need one last step, which is to solve this subtraction. Okay, so here we go. 12 and 2/10. And I need to line up my decimal points, right? Because I'm subtracting. All the soldiers line up in a row. Addition, subtraction lines up in a row, right? So here we go. Okay, here's my 0. I'm going to subtract. Okay, so I don't have enough here. It's too small on top, so I'm going to go next door. It's still too small on top, so I'm going to go next door and borrow from here. Okay, so that becomes a 1. And the 1 that I borrowed snuggles next door to get borrowed from again. And that 1 that I borrowed goes and snuggles next door. So now I have enough on top all the way around, right? So 10 minus 6 gives me 4. 11 minus 7. And then it's got a little messy, but I do have a decimal point there and right there. So I'm going to bring it straight down to my answer. And then that's it, because 1 minus 1, 0. 1 minus 1 is 0. So technically, this isn't really how you would answer it, right? You only need one of those zeros. So here we go. We are going to type in our final big answer and double check. 44/100 is what we have. Fingers crossed. I'm so confused. Where's the submit button? What? Am I being silly? Where's the submit button? Hello? I don't know what this is. That was weird. I don't know why. Oh, it's because it's my preview. Derf. Okay. It won't let me. So that's what I have. All right. We are going to end there, I guess. It won't let me actually submit anything since I just previewed it. It's not the real deal. But hopefully that helps take you through all of the main points, whether it's place values or reading a number correctly out loud, adding and subtracting, multiplying, dividing, all that good stuff. Hopefully this really helps you hone in on some of those types of problems.